So thanks all for your attendance this morning. We've got 35 in the call, so that's a really good turnout. We're going to be talking about Profinet today. So it's going to be a bit of an introduction to Profinet. We're going to talk about the theory, not too much of the theory because we don't necessarily need to know all the theory, applications, and also some tips as well, which you might come across yourself or if you engage with customers. So for those of you who don't know me, my name is Sam Kelly. I'm the automation specialist for the southwest of the country. So I typically help customers with pre-sales technical support. And I work with our partners like Underwoods quite closely as well. So this is the agenda for this morning that we're going to be going through. So as I've already said, it's not very slide heavy. The main slide heavy part is the Profinet overview, and that consists of about 4 slides, so don't worry on that. Everything in the blue text color here is kind of an example where I'll actually be showing you things in Tier Portal. So hopefully it's a little bit more engaged and not death by PowerPoint. So starting off with the Profinet overview. So our customer communication requirements kind of follow these bullet points here. Customers tend to like to have a uniform network without any network transitions. And what we mean by that is there are lots of different types of networks we see in industry. So, for example, Profibus and ASI. And when we like to have an industrial communications network, we don't necessarily want to be transitioning between Profibus, ASI, and then ultimately, Ethernet when we're going to be talking on our laptops to our devices, or indeed to higher level SCADA systems. So we'd like to have one networking technology where we can have our automation process communications as well as engineering communications and other kinds of like non-real-time communications, for example, web traffic and that type of thing. So one communications technology which sort of fits that is Ethernet. So we'll see as we go through the slides later on that the Profinet is essentially it's based on Ethernet. Okay, so some of the main benefits of having an Ethernet-based communications network is that it's pretty much standard. Well, it is standard. So we have, for example, engineering workstations, which could just be a bog standard laptop with an Ethernet interface on it, and we can communicate to our Profinet devices with that Ethernet interface. So we don't necessarily need to have a specialist laptop which has, for example, a Profibus port, or indeed you may need to purchase a USB to Profibus adapter or API, MPI adapter, that type of thing. So having that uniformity there is very good. Also, it enables us to interface up into different networks. So you'll see in later presentations in the coming days, talking about routing and this type of thing, we can actually communicate up to a higher level IT network. So this is really good because it means we can get our engineers who are perhaps sat in an office, either they could be on site or they could be away from site, for example, working from home. And by using Ethernet technologies and all the rest of it, we can do remote administration and maintenance kind of from anywhere. Also, one of the benefits of Profinet, or one of the communications requirements, is that we want to have detailed diagnostics. So we'll go through this later on in the upcoming slides, how Profinet gives rise to really good diagnostics information, and it's baked into the the firmware of each individual device, and I'll prove that later on with a bit of a Wireshark capture. So we like to have detailed diagnostics so that we can get up and running as soon as something goes wrong, and minimize our downtime. Also, reduced costs for engineering, commissioning, and live operation is always a bonus. So this is obviously one key communications requirement for which Profinet can fulfill. So just to add, actually, this presentation is going to go on for about an hour and a half, so we should be finishing about 11:30. finish about 11:15 with 15 minutes for Q&A at the end, just for your information. So yeah, Profinet, as I've already said, is basically just switched Ethernet. So it follows the the standard Ethernet, the standards for which Ethernet's based on, switching wireless as well. So we can even do Profinet over wireless. So by following these standards, we can have very flexible network topologies. So typically in industry, if you're used to Profibus, for instance, you're probably used to a kind of a line type of network. For sure, we can do that with Profinet, but we're quite flexible in that we could have a star topology, or if we wanted a little bit of network redundancy, we could have a ring network as well. Now, a ring network doesn't make sense without something managing that. So we'll talk a bit more in detail about what we use in order to manage that ring network. So we can see here at the top, we've got devices in a line topology or a linear topology, which just follows the production process up and down. Could be, for example, like a conveyor belt or something like that. And there's no need for a repeater or anything like that. The devices themselves act as a switch. So the devices I'm going to demonstrate later on, they all have an integrated 2-port switch. And of course, we're following the standards, so those ports are isolated from one another, and all the rest of it. So we don't need to purchase X number of switches to fulfill having a machine with X number of devices, because they have the ports built in. Okay. Regarding port-to-port communication over copper, we're limited to a distance of 100 meters. Now that's a standard Ethernet limitation. It's nothing special to do with Profinet or anything like that. That's part of the Ethernet standard. Okay. If we are close to 100 meters, or of course if we're going to be exceeding 100 meters, then we would need to use, for example, a fiber optic link. So from the Siemens portfolio, you may use a media converter to convert from the copper to the fiber, or if you are familiar with the Siemens portfolio, you may use, like, for example, the ET200SP remote I/O with a bus adapter, fiber optic bus adapter, to go straight to fiber on there. Okay. And if you are using fiber optic, we can go with some technologies distances of up to 80 kilometers. So you can see here it's very flexible in the types of distances that we can serve. Okay. Also, one of the main benefits is Profinet and standard Ethernet devices can coexist on the same network. It's not like we have a separate network for the Profinet devices and a separate network for web traffic and all the rest of it. They can go down the same cable, so there's no need to have a specialist cable, though we do have Profinet cables to be resilient to harsh industrial environments. But in essence, we can just use an Ethernet cable on there. So this is kind of moving on from that, where we're showing the Profinet communications channels, going down the Ethernet cable, the Profinet cable, we might want to call it. So we have kind of, when we're talking about Profinet applications, we have 3 different channels. So this layer up here is the application layer. So this could consist of things like HTTP traffic, if we've got a DHCP server on there, DHCP requests and all the rest of it, OPCUA, and then here we've got our Profinet applications. So this could, for example, I don't know, could be an inverter, for instance, and it may be using 2 of these channels. Okay, it could just use one of them. So it could just use the RT and the IRT, and I'm gonna explain the reason for this in a bit. So the standard data, what we mean by standard data, this is the non-real-time data. So this is information, for example, like diagnostics information, or it could be to do with parameter configuration. Now we can see here it's going through the TCP and the IP layers. Okay, so that means in order for us to do like parameter configuration or read diagnostics information, we have to have an IP address set up on the device. Okay. We can see here on channel 2, for instance, we've got our real-time channel. So this is for our cyclical communication. We also get alarms on the real-time channel as well. So for our automation process, we need to have real-time communication set up. And you can see here, it actually bypasses the TCP and the IP layer. Okay, and we don't necessarily need to have an IP address set up for that. And I'll give a demonstration of that later on. So we have to have something called the Profinet name set up. I'll show you that in a second. And the third channel is for synchronous communication as well. So I'll talk a little bit about that in the next couple of slides. So just keep this slide in mind for when I'm doing a demonstration in about 2 minutes time. Okay. So these are the two Profinet operating modes I was talking about. We've got our real time and we've got our IRT. Okay, so with real time, this is going to be the majority of your industrial applications. Probably 90% plus of your applications would be real time types of applications. So we have a cycle time down to 1 millisecond, and we can see here that we've got the application cycle, we have a communication cycle, and we have each individual field device cycle have their own individual processing cycles. Okay. Like I said, this is good for most applications. We also have something called IRT as well. So when you want something which would perhaps be, for example, motion control, where we have to have a high degree of precision for positioning, for example, we would have to use something like IRT. What that basically means is that we have the application cycle, the communication cycle of the network, the bus, and the field devices cycle all in sync and all on the same kind of clock. Okay, so we have to have this, for example, for motion control types of applications, or perhaps another kind of example might be, just go to a web browser. Perhaps we've got a manufacturing facility where we're manufacturing camshafts, for instance. Let's get a picture like this one here. And as part of the processing of the camshaft, we need to measure the lobe displacement with the angle. So what we want to do is we want to, for perhaps every degree, we want to take a measurement of the lobe distance. So we'd have a sensor on each of these lobes to measure the displacement, and then we'd obviously have an encoder to measure the rotational angle there. And we want to make sure that everything is sampled at exactly the same time. So at 1 degree, I want to know exactly what this height is, this height. All of these are exactly the same time. I want to know what the heights are. We have to use IRT for that type of application. So motion control, but also for IO as well. Also with IRT, we can have our cycle time down to 31.25 microseconds as well. Okay, so hopefully that give you a little bit of an introduction in kind of the Profinet theory. And I'm going to move over to some of the Profinet functions that we have in TIA Portal. Also, please cast your mind back to that slide showing you the different channels within Profinet. Okay, so hopefully you can see my other desktop now. Yep, okay. So just to show you, this is some hardware that I have next to me in reality. So I have a 1500 PLC, I have a G120 inverter, I have a scalance switch, and I have some remote I/O as well. And we can see here that the drive and the remote I/O are currently assigned to my PLC here. Just to show you in reality what that looks like. So we can see we've got our PLC here. We've got our switch, our scalance switch here. We've got our remote I/O here, and we've got our G120 drive here. So hopefully you can see, let me turn off a light. Hopefully you can see that the green lights at the top here are currently all flashing. They're not in a very happy state at the moment. We can also see that the PLC is in error. And if we look very closely down at the G120, we can see probably, hopefully, a flashing yellow light, meaning that the safety state has kind of been activated. Okay. So what we're doing is we've got an e-stop here, input into our ET200 SP, and being evaluated by the safety PLC here. So we can see that, this should be talking to our PLC. We've got it all connected and all the rest of it. I've already downloaded to the PLC, so I'm not going to do that again. So the first thing we want to talk about is the network scan. So on the online access here, we can see we've got all of our adapters available to us, and I'm currently connected to the scale and switch with this cable here. This cable here is going to my laptop, and this is what I'm going to scan the network for. So I'm just going to go ahead and do something called update accessible nodes, and that's going to, as I say, scan the network and find any accessible devices it can see. So you can see we've got our tank control PLC, we've got our G120, we've got currently an unknown device, accessible device with just a MAC address there, and we've got our tank switch as well. So that makes sense here. Everything is assigned except for this unknown device, this accessible device here. So if we go ahead and expand out this accessible device, we'll see what functions are available to us, or at the moment not available to us. Okay, that should hopefully expand out in a second. Okay. So right now I've gone onto the online diagnostics, and we can see we don't have any I&M information. We don't have any information to tell us what the device is, article numbers, or anything like that. It's still a mystery to us at the moment. So in reality, what might happen is, on a factory line, for instance, there may be a replacement of the device or something like that, and it's not talking to the PLC even though we're connected up. So a maintenance engineer might come along and he might just go ahead and assign the IP address. So you made sure to take note of what the IP address is before you'd made some modifications, and it is 0.2. I'll go ahead and assign that IP address to the device. So hopefully that parameter will be set. Okay. So we've set the IP address. However, it's still not on the controller. The PLC is still in fault as well. And if we refresh our accessible nodes here, we can see, okay, our accessible device, it's still called accessible device. Now it's got the IP address, fair enough, that's fine, that's what we did. Just wait for it to finish scanning the network. Let's expand it out, go back to online diagnostics. However, now, we've got some I&M information. So if you remember that slide I showed you earlier, diagnostics and I&M information is done via IP. Okay, so that makes sense, but we've still not got it connected to the PLC because the real-time information doesn't rely on the IP address. It relies on the Profinet name. So what we need to do is we have to assign the Profinet device name. Now, I know this off by heart because obviously I created the project, so I'll go ahead and assign that name. And then hopefully everything should settle down. Got solid green lights on there. We'll just wait for the error to clear. Now our PLC is happy as well. Also, our drive is happy now. The safety is okay. So that's fine now. The factory is back up and running. The factory manager is off our back. So that's one thing to take note of. Profinet name is most important regarding our automation process. Okay, one cool feature as well that we have since TI Portal version 15 is the online detection. Okay, so if we go here, online hardware detection, we can automatically import Profinet devices from our network. So this is quite good because it can speed up, a commissioning process. We don't have to worry about the firmware versions of interface modules and cards. We can just go on the network, detect all that information, and automatically import it into our project. So I've gone ahead and started the scan of the network already. We can see it's found 3 devices here, my G120, my remote IO in the form of ET200SP, and my switch. So I'm going to go ahead and just import this tank IO ET200SP. So now it's going to go on to the network, find the information about the device, and bring that into our project. Okay, marvelous. And we can see there's our ET200SP, complete with the slots as well. So that's a very nice feature. It saves us having to go through the hardware catalog and bring things in manually. Okay. However, I've already got it in my network, so we're not going to bother. So now I'm going to talk a little bit about the topology view. So we've seen this here. This is the network view. So this is just where we can assign devices to our controller. However, we also have this option here, topology view. So the topology view is our representation of how we actually have things wired up. So you can see here, I've got the topology view completed for these 3 devices here, my PLC, my G120, and my switch. Obviously, the ET200SP is connected to the network, but I don't have to complete the topology view. Okay. The topology view is necessary for things like our ring network, which we'll talk about later. And it also gives us a few other benefits. So, for example, it gives us diagnostics information for cables, things like that. So if I was to disconnect a cable, I would be shown that cable has been disconnected within TIA Portal. I'll show you that later on. And also we can automatically configure devices as well. I'll show you that as well in a second. So if we just look at what we have in reality, we've got, scroll that down a little bit. I've got 2 cables coming out of the G120, going into the switch. Okay, these 2 here. And then from the switch, we're going into the PLC. And then from the PLC, we're going back to the G120. So that is our ring network like we have here. And we do have to make sure that we are connecting to the correct ports. Okay. So let's go ahead and go online to the PLC. Okay, so I can see everything's healthy. And if, for example, I was to unplug this top cable here, let's go ahead and try that. Instantly, you can see we've got some error information on the devices, and we can see here that this has gone red to show us that that cable's been disconnected. So we'll just go ahead and plug that back in just to fix it. Okay. Also, what we can do with this is, let's go offline. If we just expand out this panel here on the right-hand side, we've got this option here, Topology Comparison. So with this, I can actually go out onto the network and compare how I'm wired up versus what I have in my project. So we can see here that I don't have the topology completed for the remote IO, but obviously it is connected, as we've already seen. So let's go ahead and do a comparison. What this is going to do now, this is going to go out onto the network and it's going to do a little bit of investigation and find out what our interconnections are and then present it to us in this panel here. So we'll just wait for that to complete. Okay. Can take a few seconds. Right, so. Okay, so you can see here just about everything's okay. So if we look at our PLC, for instance, that's fine. The cables are connected in reality to how they are in the project. On the scalant switch, these two ports cables here are connected as per the project. Yeah, okay. Third port here, okay, there's something on the third port which we don't have in the project. So in reality, if we look, yeah, we do have something on that third one, and it's going to our ET200SP. Okay, that's fine, that makes sense. And then we also have something plugged into port 5. That's just my laptop, that's my PG. So what we can do is we can see here as well the ET200SP. Yeah, that's not configured either. So we can choose to apply and then synchronize that with our project. So you can see it's automatically put in the link as we have in reality. Okay, so that's a nice feature. So then of course go ahead, compile that and download that to the PLC. And I'll show you one quick benefit as well of having the topology completed like this. Okay, so what I'll do is I'll just go ahead and reset the Profinet name of this device, and then we'll see what happens now that we have the topology complete for this. So go ahead, reset that, and then we'll drag this in quickly. So now we can see, hopefully, we know we've got flashing green lights as I've reset the INM, the Profinet name and all the rest of it. But because we've got the topology view set up, you know, the controller knows this is the device here and can configure it for us. If you just make sure your microphones are muted. I'll just mute you. Okay. Right. So any questions on what you've just seen so far? Oh.
This hardware detection, is it for all the Profinet devices or just Siemens right now? Which means if I connect SEW or I don't know, Phoenix contact device.
Sure, yeah. So the hardware detection in this case is just for Siemens devices. We do have to have the devices present in the hardware catalog. So say, for example, I didn't have safety installed and I was to do a hardware detection of the ET200SP here. It wouldn't bring in, I'm still showing my screen.
Okay, which means you're saying that I have to have pre-installed GSD files to do hardware detection anyway. It will not upload them from the device.
No.
Okay. There's something to develop there.
Maybe. Okay. Right, can you see my presentation yet? Yeah, okay. Right, so yeah, that completes the Profinet functions in TIA. So we talked about the network scan, the IP versus the device name, where you'd use each one. We assigned a device name. we looked at the hardware detection, and then we also looked at the topology view as well. Okay, so now we're going to talk about diagnostics in with Profinet. So with Profinet, we have really good diagnostics. It's one of the main selling features, one of the main selling points of Profinet. So we have a guaranteed alarm mechanism with 4 different levels of priority. So we've got fault, maintenance required, maintenance demanded, and advice. We also have alarm text, which is system generated as well. So we don't have to manually handball different error messages or different alarm text. It's all baked into the firmware of the devices themselves. Okay, and this text, it's based by PI, the group PI, or the device manufacturer. So we'll do some examples of that later on. We also have the identification and maintenance information as well. So I showed you earlier, as soon as we applied the the IP address, we're able to get things like the asset number, the serial number of the devices, and things like firmware as well. Okay, so it's very good, very important to be able to have these types of things, so that maintenance is nice and easy, and if things go wrong, we can get things up and running as quickly as possible. So we'll just do a couple of examples of that. Okay, so one thing to do, which is quite important when you're doing your project, is to give things, sensible names. This really helps with the diagnostics information that becomes available to us. So say, for example, let's look at this bit of remote IO here, the tank IO. I've given it that name, but also I've given each of the slots here different names as well. So we've got some standard digins, which I've called panel door buttons. We might have some panel door lights on an output card, panel door restop for our safe input signals, and contact control from a fail-safe dig out card. Okay, so by doing so, this means that the information we get in our diagnostic system is a little bit more readable by humans. So what I also have in this project is I just have an HMI. So if we just quickly look at my root screen here, and I have the diagnostics overview control, this one here, this system diagnostics one. And all I've done is I've just dragged it over to the screen, resized it. I have the connection to the PLC established here, and that's all I have to do in order to get diagnostics information. So we can see here, I've got the simulated HMI running here. Currently, the plant is okay, everything is nice and happy. If we look at our real life demo here, yeah, we've got green lights on everything, that's fine. So let's go ahead and cause a problem. What I will do is, if you can just see, we have a little toggle switch at the bottom here, okay? This fault toggle switch. What that's going to do, that's going to break one of the channels of this e-stop. So this e-stop is connected to our fail-safe dig-in card with what we call 1 out of 2 evaluation. So if we break one of those inputs, we'll have a discrepancy fault, and of course we'll trip our IO. So let's go ahead and create that fault. Okay, so I've broken the wire. Straight away we can see the modules aren't very happy. We also have a fault on our PLC here. So what the first thing the engineer would probably do is they would go and refer to their HMI screen. So here we can see, yeah, there's some maintenance required on our PLC. So let's drill down into that. We can see it's a problem on the Profinet IO system. These are the devices on my Profinet IO system. So we've got the inlet pump, we've got the tank interface module, which is where the problem resides. So let's click into that. And we can see here we've got each of the slots present on the interface module. And we can see here it's taken those names that I wrote in Tier Portal. So we can see that it's a problem with the panel door e-stop slot. Okay, so let's drill down into that. And we can see here we've got loads of information. So we've got the I&M information, the type of card it is, the order numbers, who the manufacturer is, and then we get information on the actual problem or the actual error as well. So you can see here, the FIO has been passivated, substitute values, check the diagnostics information, such as for FIO channel errors, such as wire break, short circuit, discrepancy error. Yep, that's what we've got there. We have a wire break, so it's given us some suggestions, and yeah, that's accurate. If we weren't in front of an HMI panel, perhaps we're in front of the engineering workstation. We could go online to the PLC. Straight away, we can see, yep, there's errors on the device. Let's take a look at, first of all, the diagnostic status. Just tells us, yep, module exists, faulty LED. Let me zoom in a little bit. Okay. And then if we look at the diagnostics buffer here, we can see here's the problem, discrepancy failure. Channel state 1 is 0 and the other is 1. If we scroll down a little bit, discrepancy failure, channel state 0, 1 on input channel e-stop. Okay, so that's pretty clear to us. We've got a mismatch between the two signals of our fail-safe card. So as an engineer, we'd go onto site, open up the panel door, and would see likely that one of the wires have fallen out at the back of the e-stop. So we'll go ahead and wire that back in and do the correct procedures to get everything back up and running again. And then everything should reset and our process should be good to go again. Oh, for some reason I knocked the power cable at the back, so the whole PLC is reset. Not to worry. So just wait for that to boot up again and everything should be okay. Righto. So typically you wouldn't accidentally power it off. We'll try and fix that in a bit. Okay, so let's go back to the PowerPoint. Any questions on the diagnostics information? No, okay.
Just to remind everyone, there is a chat function here. So if anyone's feeling shy and doesn't want to speak because it's being recorded, feel free to put your messages or comments in the chat, and we'll get to it as we go along. Yeah, or if perhaps you want to ask some questions at the end, that's completely fine as well. We can do that.
I've got a question regarding diagnostic. It doesn't allow you to see like I/O status as well, because I've got a lot of customers asking me, how can we see if input is on or off? Because sometimes even if it's on, it's not really on because the current is faulty, for example, or it's just basically the errors.
So in order to look at the actual status of the what the outputs are doing, for instance, you'd probably want to use something like a watch table, for instance. also we have different tools as well to look at and also force outputs as well. So if you wanted kind of information on what the the individual input is, for instance, you would have to have that like assigned to a tag, for instance, and look at that in the watch table.
But this watch table is inside the TIA portal, or this is some kind of the function of the HMI? Because in TIA portal there's watch table, obviously.
Yeah.
And this is what you're referring. The watch table inside the TIA.
Yeah. So to get that kind of information from like in the HMI, typically, people would have to create like a light board, individual.
No, this is what I do, but of course it's time consuming. Yeah, a lot of time to be honest. In some cases, if you get like 1,000 inputs, and we okay, not okay. No, I just asking because the diagnostic looks really good. Yeah, and I thought that maybe it's expanded. No problem. Thank you.
One alternative could be something like ProDiag as well. So, for example, if you had like an interlock, for instance, which was stopping you from driving output, you could actually view the code on the HMI screen, so you can see, yes, I'm sending the outputs to go high to open the to drive the lift or something, but we can see it's interlocked with a gate, so we can see that the gate signal is low, therefore we're not able to drive the lift. So that's something that you could have on the HMI panel to give you that type of information. Is that something that would be perhaps of use?
It's actually your colleague mentioned that I could use the web server, PLC web server, and I think the HMI has got option to actually embed it on the screen.
Okay, so yeah, the PLC also has a web server. So the PLC, let me just share my other screen. So have you ever used the web server in the PLC?
Yes, a little bit, not really. But,
okay. So if we just look at the device configuration for the PLC. By default, it is switched off, and this is quite relevant because we're talking web traffic over the same network. So if we look for web server, here we go.
Activate web server on this module. No, in general.
Yeah. So let me just. So you can, for example, have watch tables on there. You can also look at the status of tags on the web server as well without needing to have an HMI. So this is something that you could, you could explore.
I will do. Thank you. I will do.
If you want to have like a separate call with me after this, I'm happy to go through the web server and configuration with you.
Oh, this will be great. I will speak to Graham, to arrange it. Yeah, don't mind. Perfect.
Nice one. Yeah, just get in touch with Graham and sort that out.
No problem. Thank you very much.
Oh yeah, and as just said in the meeting chat as well. Okay. Right, so just trying to share my other computer again. Okay, so now we're going to talk about media redundancy protocol. So I mentioned right at the beginning, we have the option to have a ring network, but I also said that we have to have something which manages this ring network. So if you're just to create a ring network without anything managing it, you'll very quickly see your network like fall over as packets get forwarded from each device kind of exponentially until it falls over. So we have to have something which manages the ring. So media redundancy protocol for real-time devices can do this. So what MRP does in normal operation, so like we have at the moment in normal operation, all the cables are connected up. What the MRP manager does is it virtually disconnects or puts down a state of one of the ports to give us a virtual linear network. So if we look back, if you cast your mind back to my demo I've got by my side, I have a ring network, but the MRP manager has virtually disconnected one of these, and we just have a linear network. Okay. So one of the ring ports is blocked. So of course, for a ring network, we have to use at least 2 ports, and we call those ring ports. Okay. If we're to have a failure of a cable, or if we're to have a failure of a device, then what happens is the blocked port, so for example it could have been this one, changes state to forwarding. The network will reconfigure, and then it will reconfigure to match kind of like a new line topology like we have here. Okay, so there's some kind of things you need to be aware of with MRP. The first is that we can have a maximum of 50, that's 50 devices, and that's including the manager. Also, this reconfiguration time I mentioned as well, so when it detects a break of a cable or the downing of a node, the reconfiguration can take up to a maximum of 200 milliseconds. Now this time does depend on the size of the network. On my network, for instance, it will be a lot quicker than 200 milliseconds, but it's something that we need to be mindful, as I'll demonstrate in a second. Okay, so I'll just talk through some of the settings for how to set up MRP. Just share my other laptop again. Okay, so we've already seen that we have the topology view set up, and we have a ring network here. Okay, so that's one kind of prerequisite. We have to have the topology configured to show us what the ring looks like or what the ports are. We also need to define different roles as well. So we will have an MRP manager. Okay, so this is the device which is going to be in charge of the MRP network and do the reconfiguration and also the virtual blocking of a port. And then each of the other devices would be clients. Okay, so if we just look at what we call our MRP domain, we can see here we've got 3 devices. We have our G120, our inlet pump, we have our PLC, and we have our remote I/O. Let me just zoom in a little bit for you there. So you can see here, the remote I/O, as we've already established, is not part of the ring. It's coming out of port 3 of our switch, so that's not a device in the ring. Our G120 and our PLC are both clients. Okay, so where's the manager? The manager is our scale and switch. Okay, now it is possible to configure our switches within TI Portal, and we could set up everything like this and all the rest of it as the manager, but we can also do that in the web configurator. So I do that in the web configurator. So our switch here is our MRP manager. Okay, so customers will typically do those 2 things. They will do the topology view. Yeah, that's my ring network. They will assign the managers. Quite often it's PLC, which might be the manager, but in my case it's the switch. They'll assign the clients and think that's okay. So let's look at my example here. So you can see here everything's nice and happy. The ring network is complete. The drive is okay. Fail-safe's all good as well. In fact, let's get the motor turning as well. Hopefully the whine of the inverter isn't too annoying. So the motor's turning, albeit very slowly. And then what a customer might do is they go, well, okay, my MRP is set up. Let's test it. Let's disconnect something. So they'll go ahead and disconnect cable. Oh, wait. Why is my drive tripped? That wasn't meant to happen. We also have some errors here. That's okay. The errors make sense because we've compromised our MRP network. Our MRP network is in error, but we didn't want the drive to trip. Why is that? So cast your mind back to one of the requirements. 50 devices, okay, that's no problem. We've only got 3 devices MRP ring. The other thing is that 200 milliseconds for the reconfiguration time. Okay, that's where the problem lies. So if we look at the update cycle time for our G120, it is located somewhere around here, I think. I always forget. Should be real-time settings somewhere. Oh, here we go. There we go. So that by default, this update time here is just set to 2 milliseconds. Okay, so even though my network in reality is not taking up to 200 milliseconds to reconfigure because it's quite a small network, we need to make sure that our update time exceeds 200 milliseconds, and also have to increase our watchdog time as well a little bit. So now let's just compile that, download that to the device. So now hopefully we've increased that update cycle to more than 200 milliseconds. Now when we disconnect one of the cables, we shouldn't lose our set point. We'll still have errors on the PLC because we're breaking the MRP network, but most importantly, our process, our functionality remains the same. So let's get the inverter turning again. Okay, hopefully you can hear the whine just to prove that it's turning. Let's go ahead and disconnect this one now. Okay, the motor's still turning, the motor's still happy. Of course, we've got errors here because our ring network is compromised. In fact, if we look at the alarm information here, it tells us, drill down, port 1, port cabling configuration is inconsistent. No partner was detected, or the rest of it. Or, we could look at the online view of the topology. And we'll see that one of the cables is missing. Yep, fair enough, that's fine. So I'd go back, plug the cable in or fix the cable if someone had cut through it, whatever. The network will reconfigure. So if we still had the update time less than 200 milliseconds, it would trip again because it's doing another reconfigure. But because we've increased that IO cycle time, we don't have that problem anymore. Okay. Any questions on that?
Yeah, I've got one.
Yeah, go for it.
Because you increase the cycle time for the Profinet to refresh the data to 256 milliseconds, yeah? Does it not automatically increase the time for the safety, which means previously I had 2 milliseconds and after 6 milliseconds it just tripped. Now I actually allowing for 0.7, almost, okay, 3/4 of the second before I actually do some safety action on it.
Yeah, so when, in fact, that's something I did want to talk about. So we'll come to that later on, actually.
Okay,
just keep that in mind. Okay.
I ask you because I had real life example, yeah, with the wireless when I had to do it, and of course this crashed my safety approach.
Yes, wireless and safety can be a bit of a tricky thing to do.
Yeah, but even here it doesn't have to be wireless. But if
Yeah,
you
for sure.
putting it for 100 times longer, which means you have to consider the safety calculation, because if from 0.3 millisecond it becomes almost 1 second before something will stop in the worst case.
Exactly. Yeah, that's fine. We'll
Okay,
talk about
okay.
that here. Okay.
No problem, no problem.
Okay, so we've talked a little bit about safety as well. So you're probably thinking, well, I've just got hardware I/O wired up, but no, we can do safety over the network as well with Profisafe. Okay, so Profisafe is really good, and basically means we don't need to have any extra cable. We don't need to have any special cables either. We can just use our industrial Ethernet or our Profinet cables in order to transmit safety signals. So that all could be evaluating an e-stop or actuating the safe talk off of an inverter, for instance. With this system, we can also, we can achieve safety integrated level 3, PLE or Cat4. So we're talking about, very, very safe systems achievable with this. In reality, a lot of our customers will just use like SIL2 types of safety integrated levels. So yeah, no problem doing this with over Profisafe. So by doing our safety over the Profinet network, we have everything's fully integrated in the the one engineering tool in Tier Portal. We also get our diagnostics information through the network, like we've already seen. So, for example, when I did the breaking of one of the wires, we got the discrepancy fault come through. Standard system text that I haven't had to write, is just system generated. And one of the key benefits is that we've got just one controller which controls not only the process, the standard code, but also the fail-safe applications as well. Okay, so it's not like we have to have a standard PLC and a separate fail-safe PLC, for instance. We can have it all in one device. Okay, so when we do Profisafe, there's a few things that you have to do, which we'll go through now. Okay, so pretty much one of the first things that you'll need to do is, of course, you'd have the Profinet name set up, so we have the communication with the controller, but we also have to assign something called the Profisafe address. So what we do is we, for example, right-click our device here. We have this option down here, assign Profisafe address. And it will bring you up this window here. Okay, so here we have the PG interface set up as my Ethernet adapter. These are the safety modules that we have to assign the safety addresses to. And there's a couple of ways of doing this. We can assign it by flashing the LEDs on the front or by using the serial numbers. Nice and easy method is by flashing the LEDs. So go ahead and say, yeah, I want to assign these here. Click identification, and because these have already been assigned, because I've used them so far, the status is currently assigned. If this was a new project, that would say unassigned, and then this box here would become active and ask me to assign the Profisafe address. So if I was to click that, that would then make the lights on the front of each of these modules flash. I then identify, yep, they're the ones I want to assign the Profisafe address to, and then I'd click assign. Okay. Sorry, yeah, identification and then assign. Also, some considerations as well. So touched upon a little bit, what I'm going to be talking about now is this is not part of the MRP network. Okay. If it was to be part of the MRP network, we'd have to, increase that update cycle time, but also we need to update another time as well. So if we look down here, for the fail-safe parameters of the controller here. So default safety monitoring time for the failsafe IO on this Profinet interface X1 here, we have to also increase that value as well. And as our guest mentioned earlier as well, is this then brings into consideration, is my safety system going to be responding quick enough? If I was to hit my e-stop, worst case scenario, we could be, up to a second, before things actually get evaluated and actuated upon. So it's something that you need to take into consideration when you're evaluating your fail-safe projects. That is my response time going to be fast enough for the application? If not, you may have to do other preventative measures. For example, increase the distance between a gate or a light curtain and the process which could cause harm. So these are things that you need to take into account when you do your like auditing or health and safety analysis. Risk assessment, that's what I was looking for. Okay. So that kind of answer your question a little bit? Hopefully. Okay, also I'm doing safety, evaluating an e-stop on here and actuating the safe talk off on here, all over ProfiSafe. So the G120 as default can support failsafe. A lot of customers would do the failsafe by wiring into the I/O on the front of the panel, but because there's a Profinet session, let's do it over Profinet. So there's a couple of things that you have to do. So if we just look at the telegram configuration of my inverter, we can see here I have my my control word and my status word. Okay, so this is for the driving of the motor. Basically, you're sending a speed set point, you're sending an enable bit, you're sending a reset bit. So that's doing the kind of the standard process side of things. And then also we have a safety telegram here as well. Okay, so you'd have to add, this is safety telegram 30, for instance, and this handles the fail-safe signals. So like we have status and control, we also have status and control for the fail-safe side of things. We can then use these if we look, scroll down a little bit, we should have some addresses, I think. Here we go. Yeah, so we've got the addresses here. So we have some data types that you can download from CIOS to kind of help you along with this. And then basically, dependent on which bits are being sent, you might activate a safe talk off, for instance, safe stop, that type of thing. So that's something that you have to consider when you're doing safety on a drive, for instance. You have to have the standard telegram setup as well as the fail-safe telegrams. Okay. Okay, so I mentioned earlier that all the configuration for my scale-up switch I've done in the web configurators. So I'll go through a little bit some of the functions that we have available to us in the scale-up switch. So you've probably heard of switches and routers. Switches layer 2, routers layer 3. And this is a switch, okay? However, when we look in the web configurator, we can see here we have some layer 3 functionality. So my colleagues will explain a little bit more about these these options in the subsequent sessions, but we're going to mainly be concentrating on layer 2 types of things, okay? So this is the home page for my switch here. We can see we've got some kind of brief information here. No fault on the switch. There's a redundant power supply input. So yeah, power line 2 is up, power line 1 is down because I don't have a redundant power supply connected. So we get a little bit of kind of diagnostics information on here. We could also get this diagnostics information in our automation system as well, if we choose it to. Okay, I've chosen not to. I just want to do everything in the web configurator. So you can see here we've got loads of different options. You know, we can do DHCP, so it can be a DHCP server. Most importantly here, we've got Profinet device diagnostics. Like I said, I've got turned off. But you know, if I wanted to get the diagnostics information from the switch, for example, you know, line 2 redundant power supply has gone down. Yeah, we can get that into the PLC. But you know, I didn't necessarily want to. So I mentioned earlier at the beginning, this is the MRP manager. So let's look for redundancy. Here we go. So in layer 2, we have ring redundancy. And we can see, yeah, that is enabled. And the role is MRP manager. You can also see we've got a few other options as well. So kind of proprietary types of things. MRP is what I'm using. We also have MRP Auto Manager. Okay, so I mentioned earlier as well that the PLC could be an MRP manager. So what we could have is we could have the PLC and the switch as both MRP Auto Manager, and they would then negotiate who the manager is based on their MAC addresses. Okay, I'm not too bothered about that. That's why I just wanted to have the switch as acting as the MRP manager and everyone else as a client. We also define which ports are going to be the ring ports. So if we bring back our picture here, we can see, yeah, 1 and 2, they are my ring ports there. Therefore, I've got them configured as such. Okay. Other things that we have which are really useful, we can set up, you know, VLANs and all the rest of it, but like I said, my colleagues will talk about that later on. What's quite nice as well is we have the ability to mirror a port. Okay, what mirroring is basically I want to kind of replicate one of the ports to another, typically for the purpose of diagnostics. So what we have here, we've got port 3. I'm mirroring both the ingress and the egress, so the incoming and the outgoing of the switch. I'm monitoring both of those on port 3, and I'm mirroring that to port 6. So if we look at my webcam here, port 3 is my ET200SP here, and port 6 is currently unoccupied. Port 5 is occupied, and that's my PC. So what I might want to do is I might want to do a little bit of network diagnostics between, you know, on this port 3 here, so between the switch and my ET200SP. So I've already got the mirroring set up, as you've just seen in the web configurator. So let's go ahead and plug into port 6. Okay. And then we can use a tool such as Wireshark to look at the data going in and out of that port 3. So if we go ahead and do a little bit of a network scan, we can see loads of information coming through. What I'm going to do is I'm actually going to disconnect one of the slots. So let me just stop that. Go back to the camera. You can see I've just pulled this card out here. Okay, we'll just push it back in because I've already done the capture. And if we look, we can see here we've got loads of PNIO information. Hopefully it's not too far. I'm looking for, here we go. If we zoom in a little bit, there's the alarm information. So zoom out a little bit. Let's close that. So yeah, alarm notification, pull slot 1. Yeah, that's exactly what happened. So I've just proved to you that, you know, the diagnostics information is coming from the ET200SP itself. Okay. So this is perhaps not something that you typically would be doing in your day-to-day type of thing, but when we're dealing with complex network problems, this is the type of thing that that you would be doing, and by using a scale-up switch, we can set up the port mirroring in order to enable us to do that. Okay, any questions on that? Okay, so that's pretty much completed what I wanted to go through today. Yeah, these are my contact details. So yeah, just give us a call or email there, or of course you can get in touch with Graham at Underwoods as well. I'd like to thank you all for your time, and yeah, we've got 15 minutes left for any questions that you might have. I'll also stop the recording just in case you don't want to be recorded.